Okay, we have a quiz here. Uh, we have compound interest at annual rate of 6%. Question is, what's the monthly rate? What's the monthly multiplier? And then what's the value of a $10,000 investment at 6% compounded monthly for 8 years and then for 2 years? Okay, well, one thing is everybody seems to have interpreted my comma as a zero, so I'm going to make you invest $100,000 instead of 10,000. Okay, that way we'll be consistent with what most people are doing. If you're doing 10,000, you can adapt. Okay, so the question, what is the monthly rate? We'll reason this out. The rate for 12 months is 6%, which is 0.06. Okay, well, the rate for 1 month then, and you got this, is, everybody got this, is 0.06 over 12. Okay. Now, in a couple of cases, I had to kind of prompt you. I said, okay, if it's 6% for a year, how much is it for a month? But then people said, well, you divide 6 by 12. Okay. Now divide 6% by 12, and we're going to represent 6% as 0.06. I'm going to get rid of that percent sign so we can just deal with regular numbers. Okay. That's a rate for 1 month. Okay. Now the monthly multiplier is 1 plus 0.005. Your multiplier is 1 plus your rate. So there's a reason for that. This means then, well, now my question is, I'll tell you what it means. It answers this question. Let's see if you can answer this question. How much will you have after the first month? Well, there are two ways to calculate this. Okay. The 1 month rate is 0.005. So what's the first month interest? I want everybody to answer that question for me. Okay, now there's typically a little bit of trouble with this. Let me address that. To get the interest, you multiply the rate by how much money you've got. you multiply the rate by the principal, which equals $100,000. Now, one answer I got, how do you do that? Well, you'd say, you take this number and you move the decimal a bunch of places. Well, that's right, but you want to see that you're multiplying the rate times the principal. And that's a fundamental thing you need to understand about interest. Whatever your rate is, you multiply it by how much money you have invested. And that equals what? That's dollars and that's dollars. So say it's going to be $500. 0.005 means 5 out of 1,000. You have 100,000. So at $5 for every 1,000, 100,000 will give you 500. That's one way to think of it. But on the other hand, you just do that multiplication. You're going to move the decimal. How many places? 5 places. So it's here. You go 1, 2, 3, 4, 5. And move it 6 places. So anyhow, your interest is $500. Okay. So what's the value? The value after 1 month is your $100,000. That's $500, which is $100,500. Now, how much do you have after the second month? See if you can calculate that. You might use your calculator to calculate that one. All right, now after the second month, well, we get to multiply our amount by 0.005 again. Now there's a temptation just to double the 0.005 because it's 2 months, and that would make sense if this was simple interest, but this is compound interest, which means we multiply the 0.005 by this number, the number we have after a month, which is more than the amount we started with. So we're going to get a little more interest. Okay. So interest is our interest rate, which is 0.005 times $100,500. Put a dollar sign in there. And that's going to be $502.5. which is $2.50 more than the interest we had last month. Okay? Well, it's principal. You know, somehow these numbers. Okay. $101,000 and $2.50. Okay. We can go on with this a little bit. But parallel to the calculations I've done here, what do we get if you multiply $100,000 by 1.005? Calculate that. You didn't need, you did, okay, some people use the calculator. You don't need the calculator. Multiply 100,000 by this, you're going to move the decimal over 1, 2, 3, 4, 5 places. You get this. Okay. Now you notice that this is the same as this. Now, should that be any surprise? Well, if you're multiplying by 1.005, it's the same as multiplying by 1.005 and then multiplying by 1 and adding the 2. In other words, 1 times $100,000 is $100,000. That's your $100,000. 1 times 100,000. And 0.005 times $100,000 is your $500. So if you just multiply by 1 plus 0.005, you get $100,000 plus $500. Okay. That's the same as 1 plus 0.05 times $100,000, which is $100,000 plus $500. Okay, that's why this gives you the same thing that this did. Okay. After another month, you have what? You have 1.005 multiplied by the $100,500, which gives you and that's the same thing that you had here. Now let's understand that okay, this is same as this. Because how did we get this? We multiplied 1.005 times 100,000 to get this number. Does that make sense? And that equals what? These are just all multiplications, so we just write them without any parentheses. That's going to give us the same as just multiplying 105 squared by $100,000. Try that. Use your calculator, square this and multiply it by $100,000. Okay, if you do that, you find that this equals $100,001 and $2.5, same as this, right? So we could do a little more calculations, but convince ourselves even more, but we can make this table. P for principal. $100,000 after, well, month 0, okay? New principal still $100,000. I don't like the word writing that. Month 0 doesn't make a lot of sense. So we'll say month 1. The principal start is $100,000. Principal M is the principal at the start times 1, which will give you your $100,000, plus 0.005, which gives you your interest, $250. So you get $1.005 times $100,000, which equals $100,000 and 500. So for month 2, you apply this to the principal at the end of month one. So at month two, you start with 100,000 and you end with $1.005 times $100,500, but that's equal to $1.005 squared times 100,000, because you're multiplying this by 1.005, but you got this by multiplying your 100,000 by 1.005. So you've multiplied by 1.005 twice to get this. And you got 101,000 and $2.5. So in the third month, you start with this. And I could write out now, at the end, you're going to have 1.05 times this number, right? But you can see that this is equal to this number. So when I multiply this by 1.005, I get 1.005 cubed times $100,500, okay? So I'm not even going to write that out, because what I want to know is how much do I have after 8 years, which is 96 months, okay? So what do you think this is going to read after 96 months? Can you write it down? Okay, so by month 96, this is going to come out 1.005 to the 96th power times the original $100,000. Okay. Now your formula is P equals I'm going to call it P sub zero, the amount of money you started with, the time zero. Okay. Times 1 plus R over 12. Because remember, we started with a rate of 5%. Okay. So R over 12 in this case is 0.06 over 12. R is 0.06. So R over 12 is 0.06 over 12. There's your 0.005. And if T is in years, you raise it to the 12T power, because how'd you get 96? Well, it was 8 years, so you multiply 12 by 8. Okay? But now you can calculate it for any number of years. Well, this equals p sub 0 times 1 plus 0.005 to the 12t. Okay. And this is an exponential function. So I'm going to take this just a little further. I'm going to say this is the original principle. I think some of your open math at least uses A for amount. And that's okay. That's a good letter, but I like to talk about principle. Okay. The principle multiplied by this number to the t. Now, what's 1.005 to the 12th? I can kind of estimate that. It'll be like 1.067 or something like that, maybe. And that's probably a bad estimate. So use your calculator and figure 1.005 to the 12th. Okay, my estimate was pretty bad. I could have done better than that, but okay. Well, this means we can write the principal as a function of time. P of t is just an exponential function, like ab to the x, so this is ab to the t. What do we write that? A is 1.005 to the 12th, which is approximately equal to 1.0616. And notice that when we rounded off this result, 1.0616, it became approximate because there were more decimal places after that 6. And B, you know, this is B that's equal to 1.0616. That's the base of your logarithmic function. And A equals P sub 0. So here's one way of calculating it, which is completely accurate. This 1.0616 has several more decimal places. Okay. But if you include all those decimal places, it does terminate. Okay. If you include all those decimal places, it would be exactly equal to this. And that's how you can calculate how much money you're going to have after any length of time. Okay? So try to understand this. This is practically useful. Okay? You're going to be buying things. You're probably going to be buying things on credit. You're going to pay interest. Okay? You're going to probably put money in a bank or something. And draw interest on it. You want to understand what's going on and why compound interest is important. Now, there's the other thing, and I think most people didn't get to this part. If you compound interest 12 times, you end up with a higher effective interest rate. You end up, instead of 6%, you end up with 6.16%. Okay? If you compounded it every day, that'd be 360 times a year. Usually they assume 360 days in a year and call that daily. They don't use 365.254, whatever it is, days in a year. Okay? You get a higher interest rate. The more times you compound it, the higher the interest. Okay? There's this thing called continuous interest. Okay? Continuous interest of 6% is P of T equals P naught times E to the RT. Which is P naught times E to the 0.06T. So what is P of 8? And we'll call this P sub C for P continuous. And C means continuous. And you don't have to substitute $100,000 for P naught. This will apply to any principal, okay? But what do you get for E to the 0.06T? Which T equals 8 years. Okay, so when we calculate this for P of 8, we get P naught times 1.6160744. Now, if I multiply that by 100,000, I get $161,607.44. Okay? Okay. Can you do 1.0616 to the eighth? Yeah,
Is it 1.0?
well, yeah, this is 1.0616, which is what you got previously.
$4,879.
Let's see what happens.
Is that what you want?
Go back. So, I don't think so. Oh, okay. They're supposed to raise it to the eighth power. See, the 1.0616 is raised to the eighth power. So let's see if we can. Oh, this out. And raise that to the eighth. So it's x to the power. Is that it? Okay. Let's see. No, that's not it. Okay. So what we do is, okay, take 1.0616. And we're not dividing with 0. Get off of there. Okay, 1.0616 raised to the eighth power. Okay. Equals. Now that should look pretty familiar. 1.61319. Okay, so read it off to me. Okay, it's gonna be 1.61. What comes after 61?
319.
319. And
652.
okay, now if we take that to the $100,000, stop at the 5. If we had $100,000, that'd be $161,319.65. Now, this gives us 161,600 and some dollars, okay? So this gives us almost $300 more than this one. That makes sense? Okay. Then if you did this one, you'd come out with something a little bit different because the 616 wasn't the whole number you got when you raised 1.005 to the 12th. Okay, so if I use the accurate model, 1.005 to the 12th to the 8th, which is going to be 1.005 to the 96th power, I get 1.6141427 as my multiplier, which would correspond to $161,414 approximately, as opposed to $161,319. Okay, almost $100 more. And that's what happens if you round off too early. You don't get something that's completely accurate, which is why I said if you do this thing and carried this number all the way out until it stops, then you would get exactly the same thing you would get here. Okay. All right. And that's as much as I'm going to talk about the compound interest, except that this is an exponential function. And if I did the exponential function, I take it back. I'm not going to do that yet because we got to get logarithms first. And that's the next assignment. So let's talk about that some. Okay. The function y equals 2 to the x if x equals 1 here, x equals 2 here, x equals -1 here, and we could go as far as -2. But I also want x equals 1/2. Maybe a little hard to read that. X equals -1/2. Okay. So anyhow, that's x equals 2. Divide that in half. You got x equals 1. Divide that in half. You've got this. Let's put y equals 1 here. Okay, 2 to the x has values 1/2 here, 1 here, 2 here, and I don't know why I put x equals 1/2 in there. That made no sense. And it equals 4 here. One half ought to be a little higher than that. So the graph is going to look like this. This is y equals 2 to the x. Now you can do that by subdivisions and so forth. Okay. Now y equals 3 to the x would be, and we drew this earlier, but y equals 3 to the x would be down here, here, and it would be up here at x equals 3. We would get x equals 1. And then it keeps going up faster and faster. So it's low here. And it's high here. Now the points that we have on the 2 to the x graph are, and kind of screw that up. We'll change the shape just a little. We're at this point, and we don't have a point on this curve. So it comes up like so. In this one, the 3 to the x turns out to be like the blue graph. Y equals e to the x. E is between 2 and 3, but a little bit closer to 3. E is about 2.7. Open math will tell you about that. But the graph of e to the x goes in between these and probably closer to the 3 to the x graph. So this is y equals e to the x. Each of these has an inverse function. Inverse of y equals 2 to the x. Well, let's just using x values -1, 0, 1, 2, we get 1/2, 1, 2, 4. Now we do a graph of y equals log base 2 of x. Log base 2 of x is inverse to 2 to the x. So how do you do inverse functions? You swap columns. Second column becomes the first. And the first column becomes the second. Now, if we graph these points, we have 1/2, -1, that would be a point here. We have 1, 0, that would be a point here. We have 2, 1. Well, here's x equals 2, here's y equals 1. And then out here, we better have a line for x equals 4. And that's the point where y equals 2. And we get this curve. Okay. So the y equals log 2 of x curve is here. The 2 to the x curve is here. Typical inverse function. Okay, now how much you picked up from inverse functions up to this point? Well, you might want to review it a little bit, but it's just swap x and y. Then the e to the x function has an inverse. And the inverse of that function will look something like this. Might be hard to read. That's log base e of x. This chalk is just a little bit hard to write with. We call that ln of x the natural log of x. So those are the graphs of the log base 2 function and the log base e function. Give you one property, but we're just out of time. So I'm not going to give you that property. I have to use a natural log notation. I want you to digest that first. Okay. You have other properties of logarithms. This is where they come from. This is how they're defined. And Open Math is going to tell you more about some of their properties, which are not too difficult to apply. So let's see how you do with those. Okay. We spent a lot of time talking about compound interest, but that's I regard as a very fundamental thing to understand. So we will go on then with some logarithms, and then I can tell you more about compound interest, like how long does it take your money to double and so forth. So that's kind of where we're headed.